चलिए वापस पे आ जाते हैं. Uh, अच्छा, then you have redox processes. उसके लिए you must know how to balance redox equations. ठीक है. You have to balance the number of electrons that are lost and gained. ठीक है. Whenever you have a redox equation, you are going to balance the number of electrons lost and gained. तो ये पता होना चाहिए, and remember that's important because you'll be doing electrochemistry. Just a second, where did electrochemistry go? अच्छा नहीं, यहाँ से start हो रही है. अच्छा, so wait a second. हाँ ठीक है. अच्छा, so electrolysis, you must know how electrolysis works. This is a physically we did questions on this. That's the Faraday constant. That's the charge on 1 mole of electrons. You must know how to do electrolysis. ठीक है. For example, एक आध कर लेते हैं. ठीक है, साथ ही ना. अच्छा, साथ ही एक practice भी साथ साथ करते रहते हैं. कि for everything I'll just do a small question just for revision. ठीक है, just a second. अच्छा, so now you would know electrolysis. So I'm just going to quickly do the electrolysis of some random copper sulfate का कर लेते हैं. ठीक है. So here are 2 electrodes. Now remember, electrolysis converts electrical energy. So you have a battery, and they convert it into chemical energy. This is your negative. ठीक है. This is your positive. And इस side पे electrons are being sent. So substances would gain electrons. On the other side, electrons are being lost. So if I have copper sulfate aqueous in my solution, so my solution is going to have 2 ions. One is going to be copper 2 plus over here, and the other one will be sulfate SO4 2 minus. But apart from that, there's going to be 2 other things. Mariam, क्या होगा इसके अलावा क्या होगा? बल्कि one other thing actually.
Sir, H plus ions?
No, there's not going to be any H. I mean, remember,
Sorry,
ठीक है, there's going to be water, and water would be on both places. ठीक है. Remember, there is in A levels electrolysis, you assume that water doesn't really ionize a lot. ठीक है. We already know that from equilibria as well, that it doesn't ionize because the concentration of these ions is very, very less. It's 1 times 10 power minus 7 mole per decimeter cube, which is, and this one is the same, which is almost non-existent. So now, how do you do A levels electrolysis? Substances that reach the cathode, they're the ones that are going to gain electrons. So at cathode, these are the substances that would be gaining electrons. So it's either water that's going to gain electrons, or it's copper 2 plus that's going to gain electrons. And electrochemistry का क्या rule है? Who gains electrons? The highest E naught is the one that gains electrons. So I think I have a data booklet somewhere. Just a second, not this.
Also, sir, there's so many reactions for water. How are we supposed to know which one to use?
नहीं, वो यूसी पे आ रहे हैं. Just a second. Where did my आ गई data booklet? अच्छा, so if you go back, we're looking for equations where we want the substances to gain electrons, right? And remember, okay, in the data booklet, जो electrochemistry का table है, substances gain electrons in the forward direction. Okay, so we're not looking at the reversible reaction, we're actually just looking at the forward reaction. We're looking at them gaining electrons. So copper 2 plus and water. So I want copper 2 plus and H2O to be on the left side. Where's the electrochemistry? Yeah, no. So I want copper 2 plus. So there's if we look over here, if we look over here, there's copper 2 plus. This is one of the equations, and there are actually two equations right next to each other. So I have two reactions: copper 2 plus gaining 2 electrons, so that's one, and copper 2 plus gaining just 1 electron. One is 0.34 volts, the other one is 0.15 volts. And who else is gaining electrons? Water. So where is water? So I've got water over here. ठीक है, and water is gaining electrons. ठीक है, forward के अंदर water is gaining 2 electrons, and the value is minus 0.83 volts. Or देख लो left side where water should be on the left side, it should be gaining electrons. There is no water. I mean, there's water over here, but you can't use that equation because there's HO2 minus 1 as well, which we don't have. यहाँ पे भी water है, but we don't have oxygen, so you can't use any of the other equations because you don't have the other substance. मतलब water के साथ oxygen है ही नहीं, तो where do you get oxygen?
Yeah.
So you're,
Okay.
so you're left with these three equations. And so water or copper 2 plus, who's going to gain electrons? The one with the higher E naught. Okay. So who has the higher E naught in this case? It's going to be कौन है इसमें? The first one, right? So it's going to be copper 2 plus. That is the one that has the highest E naught. So it's going to be copper 2 plus, that would be depositing. Do all the working over here on the data sheet, and फिर वहां जाके ना बस answer लिख दो कि it's copper 2 plus. It likes to gain 2 electrons to form copper. Why? Because it had the highest E naught, it had the highest tendency to gain electrons, which was 0.34 volts. Is this clear?
Ji sir.
I said then you've got the side, okay? You've got the anode side. वहाँ पे क्या होता है? The substances, I mean, anything that comes over here, the battery is going to pull electrons away from it. So it's going to lose electrons. So there's going to be a loss of electrons happening. Who loses electrons? The one that has the lowest E naught. Okay, that's the one that loses electrons. So you've got two options. अब इसके अंदर equation जो है ना वो backward में देखनी है. In the data booklet you have to look at the equation in the backward direction. Remember electrolysis के अंदर there's no reversible sign. ठीक है, don't write reversible signs. Just look at the equation in the backward direction. So SO4 2 minus and H2O. देखिए, अच्छा SO4 2 minus and H2O. So find H2O on the right side. So there's one equation over here. There are actually two equations for water. Okay, water losing electrons, so to form this, water losing electrons, and it's forming this. So I've got two equations, 1.77 and there's 1.23, and then you have SO4 2 minus. Where is SO4 2 minus? It's this one. So you've got SO4 2 minus as well, and that's 2.01 volts. Now, who likes to lose electrons? The one that has the lowest potential, which in this case is the 1.23 volts. It's this one. So you get the 2H2O turning into O2 plus 4H plus 1. So it's 2H2O, which is turning into O2 plus 4H plus 1 plus I think 4 electrons. Why? Because it had the lowest E naught. It had the highest tendency to lose electrons. So you have 1.23 volts है. ठीक है? Is this clear?
Ji sir.
अच्छा एक second रुक दो, even somehow turn off the notifications. Just 1 second. अच्छा then, so that's one thing. फिर इसके अंदर concentration plays a role. Always remember that concentration is going to have an effect on the E naught values. Like if you have multiple equations, for example, what if at our anode you had Cl minus 1? Okay, let's say you didn't have copper sulfate. You get a lot of questions on Cl minus 1. So let's say you didn't have copper sulfate, instead you had copper chloride, and copper chloride was concentrated. तो यहाँ पे there was instead of SO4 2 minus there was Cl minus 1, right? And if you go back and have a look at the data booklet to Cl minus 1, now there is no sulfate, so I'm going to rub this off. Okay, I've changed the question a bit. Now instead you had Cl minus 1, which was somewhere over here, Cl minus 1 losing electrons. It's 1.36 volts. Then you would notice that this Cl minus 1 और वो जो water वाली है उसकी equation में there's hardly, it's 1.36 volts, and the one with water, the one that we selected, was 1.23 volts. Now, when the potentials are very close to each other, then concentration is going to play a role. Why? Because if you make Cl minus 1 very concentrated, then the equilibrium would automatically shift backwards. And if it shifts backwards, the potential decreases. So it might become 1.15 volts. So so if you compare all the three, then Cl minus 1 would become the lowest potential. And if it becomes the lowest potential, then Cl minus 1 is the one that's going to get discharged. Okay, clear? So remember this, okay, the potentials, these are standard potentials and they can change if you change the concentration of the ions in the solution. Clear?
जी sir.
So then you have described the determination of the value of the Avogadro constant by the electrolytic method. Now, Faraday constant, let's do a question on Faraday constant very, very quickly. Okay, let's say there's copper getting deposited. So the question is, what would happen if this electrolysis of copper sulfate happening, and this is the reaction that's happening at cathode that we discussed above. So copper is getting deposited, and the question is asking, you're going to get simple questions on this, and the question is asking what mass of copper would be deposited. So they're looking for the mass of Cu if electrolysis happens for, let's say, 2 hours, and it happens for there's a current I, which is 2 amperes, and it happens for 2 hours. So what you're going to do is you're going to do Q is equal to IT to find the total charge, which in this case is going to be 2 into 60 into 60. That's the time in seconds into 2 amperes. ठीक है, तो total charge आ जाएगा, which is going to be what? अच्छा, calculator ही नहीं है. Do you have a calculator?
Yes sir, I'm doing it. Sir, it's 14,400.
ठीक है, 14,000. अच्छा, just 1 second. अच्छा, छोड़िए. अच्छा, 14,400.
जी sir.
Coulombs. Now, you're going to use Faraday constant, which is the charge on 1 mole of electrons, and that's going to be 96,500 coulombs. So using that, find the moles of electrons.
Sir, it was 0.149.
It's 14, just 1 second. So it's 14,400 coulombs, right?
Yeah.
So cross multiply, you get how many moles of electrons?
0.149.
अच्छा, you're going to get 0.149 moles. अच्छा, एक चीज का ख्याल रखना है कि make sure your values that you write on your paper, they are always up to 3 significant figures. लेकिन make sure don't try to round off values on your calculator. ठीक है, यानी अगर ये value बहुत बड़ी आ रही है, just use 0.149 and then there are certain decimals coming after that. Keep using that value on your calculator. ठीक है, don't round off values on your calculator. So you've got 0.149 moles, and based on the ratio, you can find the moles of copper, which is going to be half of that. So कितने moles are?
Sir, 0.046. Sir, 0.0746.
746. And you can multiply the moles by the MR and AR, which in this case would be, I think, 63.5. But always make sure that use the AR के अंदर भी ना people make mistakes. They just remember ARs and they just write it. And remember कि आपका जो periodic table है ना, that's kind of more accurate. You're going to lose marks if you don't use the more accurate value. जिसमें
Sir, we get
fine.
4.74.
ठीक है, पहले मैं कॉपर देख लूँ. It is 63.5. लेकिन ख्याल रखना है, कैल्शियम, don't take calcium as 40, it's 40.1. ठीक है, don't take magnesium as 24, it's 24.3. ठीक है, you have to be careful. मेमोरी से ना करना, make sure you open the pure table when you do this. अच्छा, क्या आंसर है?
Sir, it's 4.74.
So you get 4.74 grams. Anyways, so these are the type of questions that you're going to get for this. उसके बाद है कि
Sir, but how do we do the Avogadro's constant, Pada?
it's the reverse. The way you're going to do that is कि you would know that one electron has, let's say the question is, I'm just making this question up. Okay? We're probably going to get a wrong value for Avogadro's constant, but this is how it's going to happen. Okay, let's say they tell you that 4.5 grams of copper is deposited, right? And when is it deposited? When you probably follow कर लेते हैं. हमारी कितनी value थी? 4.74. So let's say 4.5 grams of copper is deposited when a current is passed 2 hours and 2 amperes. Okay, so a 2 ampere current is passed for 2 hours. Right? That's the electrolysis that's happening. So we're aiming to find the Avogadro's constant. अच्छा, इस case में find the moles of copper. ठीक है, how many moles of copper do you get? It's mass divided by AR, which is 4.5 divided by what? Divided by 63.5. तो क्या value आ रही है?
So we're getting 0.0709.
0.0709 moles, right? Achha, now based on that, we know that the equation is that copper 2 plus gains 2 electrons. We did the electrolysis right at the beginning, so we have this. So up reverse, we found the moles of copper, right? Now based on that, double that, you'll find the moles of the electrons. Can you find the moles of electrons?
So 0.142.
So you're getting 0.1442 moles, right? So you're getting 0.142 moles. Ab moles aa gaye uske. What is the charge? We've already done this calculation, Q is equal to I into T. ऊपर से copy कर लेते हैं. It's 2 into 60 into 60, right? So how much कितना आया था? 14,400? हाँ. So this you got 14,400 coulombs, right? Now you found this thing. You found that there's 0.142 moles of electrons, right? You found 0.142 moles of electrons, and you found the charge, which is 14,400 coulombs on that. Okay. Now, based on that, what you can now do is, since you have found the charge, you can figure out how many electrons do you have, because you know that one electron has a charge of what? It has a charge of 1.6 times 10 to the power minus 19 coulombs, right? You know that. So in दोनों को divide करो. अच्छा, इन दोनों को divide करो, you'll find the number of electrons. How many electrons do you get?
Sir, we're getting sir, moles of electrons or the Coulomb value?
This will give you the number of electrons, not in moles. It's like one electron has a charge of 1.6 times 10 per minus 19 coulombs. So the total charge that you have is 14,400 coulombs. So if you divide that, this will give you the number of electrons.
Sir, it's 9 to 10 power 22.
Kitna 9? 9
Wait,
what?
sir, I'm really. Do we? Oh, okay, never mind. Take a hold on. Sir, I got 6.35 into 10 power 23.
नहीं इसका क्या आंसर आया था 14,400 divided by 1.6 times 10 per minus 19.
Oh, so that was 9 times 10 power 22.
Exactly 9.
Yeah.
So you're getting this, right? Probably 9.00, right up to 3 significant figures. Now this is the number of electrons, not in moles. It's the number of electrons. Okay. So now you can use ratios, right? Like, what was Faraday constant? Faraday constant was right now we're trying to find the Avogadro's constant. So Faraday constant was what's the charge of 1 mole of electrons, right? So if I have 1 mole of electrons, I mean I can use ratios, and I'll get the Faraday constant. So not the Faraday constant, sorry, the Avogadro's number. Is that clear?
Ji, sir.
Okay, 0.142 moles had these many electrons. So if you had 1 mole, how many electrons would you have? So what's the answer you're getting?
Sir, 6.35 into 10 power 23.
Into 10 raised to power 23. Okay, so you're getting that. So this is how you're going to do that. You're going to find Avogadro's constant. If you want to find Avogadro's constant, you're going to bring in 1.6 times 10 power minus 19 coulomb. You get the fact that one electron has a charge of this. So you can find the number of electrons in that particular charge. And
ठीक है.
फिर वो खाली रेशो लगाना है कि फिर what would 1 mole be equal to? That would be equal to these many electrons. So then that's
Sir,
F
can we
is
also find our own Faraday's constant by doing the ratio and then using F is equals to LE and then finding Avogadro's like that?
exactly you can do that. Okay, for example, in this case, you know that I mean you can find the Faraday constant as well using the same values.
Yeah.
Like 0.142 moles has this many charge, right? So what is Faraday constant? Faraday constant is the charge on 1 mole of electrons. So you can use ratios and find the charge on 1 mole of electrons.
Yeah, okay. And then F is equals to LE.
You don't actually you have to use ratios. You can't use F is equal to LE. Okay, F is equal to LE के अंदर ना the problem is कि उसकी values fixed होती हैं. मतलब F is equal to LE is not everything is fixed. E is 1.6 times 10 per minus 19, L is 6.02 times 10 per 23, and F is 96,500 coulombs. ठीक है? So F is equal to LE is not an equation. It's a fact. समझ आई बात? But उसके अंदर there is no y, there is no x, there are no variables. You get the point?
Okay, sir, but then that's how I got the last answer. How did we do it? Wait, so we got 9 into 10 power 22 electrons, and then उसके बाद हमने क्या किया था?
वो था ना कि we had to figure out कि what's 1 mole equal to. I mean 0.142 moles of electrons, 0.142 moles of electrons is equal to these many electrons, right? So we just use ratios. Okay, if 0.142 moles has these many electrons, then 1 mole would have how many electrons? We got this.
Okay, makes sense.
ठीक है. वो बस याद रखना, you can't, F is equal to LE is not an equation, it's just a fact. मतलब उसके अंदर there is no variable, everything is fixed. ठीक है, so you can't really input values into this and find something. बल्कि वो अगर तो खैर you can do that if you've already found the Avogadro's constant, the wrong one. वो फिर इसके अंदर डाल के ना you can use it, you can find F.
Yeah. ठीक है.
ठीक है. अच्छा, so next one is standard electrode potential. Remember, वो जल्दी से revise कर लेना. There are going to be 3 types of electrodes. So 3 types. One is going to be metal with its aqua signs. You'll be asked to draw them. So for example, if there's copper and copper 2 plus, so the electrode would look like this. The electrode would be copper. Okay, so this electrode would be made out of copper, and the solution would contain copper 2 plus, and it would contain copper 2 plus, and the ions, if it's a standard electrode, it should have a concentration of 1 mole per dm cube. वो लिख भी देना अगर if they're using the word standard. The other type of electrode is going to be if it just contains aqua signs. Now, if it just contains aqua signs, then it's going to be a solution, and the solution is you're going to add a platinum electrode into the solution. So there's going to be a platinum electrode, and दोनों ions जो होंगे ना, let's say there's this equilibrium that's established between Fe3 plus trying to gain electrons to form Fe2 plus and vice versa. Fe2 plus trying to lose electrons to form Fe3 plus. So let's say you have this. Both ions are going to be part of the solution. ठीक है, जो भी हो रहा होगा gaining and losing electrons, that would be happening in the solution. And if somebody wants to gain electrons, it would gain electrons from the platinum electrode. If somebody wants to lose electrons, then it would lose electrons to the platinum electrode. जो भी charge build up होगा, that would be built up on the platinum electrode. So that's the second type. Of the third type है कि if it involves a gas. So whenever an electrolysis is involving a gas, not electrolysis, an electrode is involving a gas, then there's going to be a gas jar. There's going to be an inlet for the gas jar. For example, there would be well, pick any random electrode. Let's इधर से देख लेते हैं data booklet से. अच्छा, let's pick any complicated कुछ involving gases. A second. अच्छा, ये वाली कर लेते हैं. O2 and 4H plus 1 and H2O, right? So this one, the O2 gas would be coming in, and the solution would contain H plus 1 aqueous. So it would contain H plus 1 aqueous, and aqueous meaning water तो by default वैसे ही होता है, ठीक है? So and you're going to insert a platinum electrode. ठीक है? So there's going to be a platinum electrode that's going to be present. That should be clearly labeled. तो ये आपके ना 3 types के electrodes हैं. Each one would be made in this way, ठीक है? Depending कि वो कौन से type का है. अब उसके बाद है कि what's describe the standard hydrogen electrode, ठीक है? So it's this electrode where that's your reference electrode, जिसके अंदर the gas is H2 and the solution contains H plus 1 ions. So the reaction that's happening over there is 2H plus 1 plus 2 electrons plus 2 electrons in equilibrium with H2. And this is your reference electrode, so the E naught is always 0.0000 volts. Everything is compared using the hydrogen electrode, so it's either more positive or more negative compared to the hydrogen electrode. और main rule की electrochemistry का कि high potential का मतलब है कि it has a tendency to gain electrons. High E naught means it likes to gain electrons, and vice versa. If you have lower E naught, then that means it likes to lose electrons. So that's the main चीज ये फिर एक describe the standard hydrogen electrode फिर एक cell कर लेते हैं quickly कि describe methods used अच्छा ये तो हो गया calculate the standard cell potential so we can draw a random cell इसी का draw कर लेते हैं just one second let me copy this अच्छा एक ये copper 2 plus और एक हम कर लेते हैं Fe3 plus वाला so I've got two you connect two electrodes together you get a cell what are the two reactions that are happening इधर क्या हो रहा है इधर it's copper 2 plus trying to gain 2 electrons and vice versa copper trying to lose 2 electrons यहाँ पे जो E naught value that's 0.77 volts that's in the data booklet और यहाँ पे जो E naught value that's 0.34 volts so you're going to connect the two electrodes together and there's going to be a voltmeter in the middle and there's going to be a salt bridge that always needs to be added to complete the circuit. As I said, it needs to be there. Now, as I said, it needs to be there. And just one second. As I said, it has to be there. And which side, the higher potential is the one that's going to gain electrons. So ये वाली side जो electron gain करेगी, it's going to gain electrons. If you connect the two, so you'll be asked to write the equation. तो ये forward चला जाएगा, it's going to gain electrons because it's the higher potential. Electrons always flow towards the higher potential. This is 0.77 volts, and this other one is 0.34 volts, right? So electron flow के ऊपर question आएगा. You'll be asked about okay, which direction electrons are flowing. This side would gain electrons. It's the higher potential. ठीक है, that's the main rule. और जो दूसरी side है, that's your lower E naught. So that's the one that's going to lose electrons. So that's the one that's going to lose electrons. So it's going to go in the backward direction. So that's what's happening, and you'll be asked to write. You'll be asked to mention the E naught cell. The E naught cell is the potential difference. Usually, it's the higher potential minus the lower potential, which in this case would be reduction potential minus oxidation potential. In the right side, higher. This is the reduction side, and this is lower. That's the oxidation side. So it's going to be higher minus lower, which is 0.77 minus 0.34. Or value आ जाती है 0.43.
Sir?
Volts. Yes.
Sir, so basically when R delta H is negative, R delta G is also negative, and E naught cell is positive, these three things make reactions feasible?
Yes, E naught cell should be positive. ठीक है. And now when it comes to thermodynamics, when it comes to energetics, then you just focus on delta G. What's the third thing that you said?
Sir, delta H being exothermic.
That is not what it usually depends on. I mean, delta H being exothermic doesn't necessarily guarantee you that it's going to be a feasible or it's going to be a spontaneous or a non-spontaneous reaction. So,
okay.
So it's delta H being negative, that's favorable. Delta S being positive, that's favorable, but it won't determine whether it's going to be spontaneous or not. It's going to be delta G. It should be less than 0. Okay?
So delta G less than 0 and E naught cell greater than 0.
Yeah. And if still the reaction is not happening, that just means that it has very high activation energy.
ठीक है.
अच्छा, अब ये कि you've got अच्छा, we can make the equation also. Just one second. The overall equation. So there's right side one that's going forward. So write it in the forward direction. That's plus 1 electron, turning into Fe2 plus. The left side one is going in the backward direction. So that's copper, losing electrons to form copper 2 plus, plus 2 electrons. And you've got, you multiply the first one, balance the number of electrons that are lost and gained, and then you add the two equations up. So the overall equation is going to be that it would be 2Fe3 plus Cu, and the product is 2Fe2 plus Cu2 plus. So that's your overall reaction. और फिर इसमें E naught cell का role याद रखना कि E naught cell, the more positive it is, the more spontaneous would be the reaction. If the E naught cell is, let's say, 1 volt, so you'll be asked questions. How do you increase the? How do you make it more feasible? How do you increase the value of the E naught cell? So Mariam, how would you increase the E naught cell value? Like, what should you do? What changes should you make to this solution over here?
You should make the iron electrodes make it more positive, so increase the concentration of Fe3 plus or
Okay, so
decrease
you want to make,
Fe2.
so okay, so you need to make this higher, then the E naught cell would be higher, and the electrons would flow a lot quicker. So you need to shift the equilibrium further to the right, and you can do that. Remember, if you want to make it more positive, you have to make it move to the right. You have to make it gain more electrons. So Fe3 plus concentration could be increased, or vice versa. Fe2 plus concentration could be decreased. और उल्टा क्या कर सकते हो? You can make this lower. You can make this more negative, more lower. How do you lower this? You have to make it produce more electrons. So you can decrease the concentration of copper 2 plus. Okay, so you'll get questions on this. Clear?
Yeah.
अच्छा, फिर ये कि अच्छा, इसके बाद और क्या है? Explain, deduce the direction of electron flow. Deduce the E naught values, the relative reactivity of the elements. So we can talk about that. इसमें पहले ना first thing nernst equation भी बीच में ले आते हैं. Non-standard, ठीक है, for non-standard conditions, you'll have the nernst equation, which was given over here. कहाँ पे? यहाँ पे लिखी हुई थी. E naught plus 0.059 z over z log of oxidized species over reduced species. So let me write that. It's E is equal to E naught. You have to remember that. Most of the questions that's already given, but still you have to memorize this. As a 0.059 divided by z log of. Now, oxidized species is the one that is formed after oxidation. That's the one that's on the left side. If you look at the data booklet.
Sir, can we just remember that it has the higher charge or the high oxidation state?
हाँ चलो, लेकिन वो a lot of times the oxidation states are not really, I mean, that would just be a little more tedious. I mean, that's right. I mean, for example, if you look at this reaction, let's say this one. I mean, the VO3 minus 1 VO2 plus 1, right? तो वो फिर एक extra step आ जाएगा कि you would have to calculate the oxidation state first. Do you get my point?
Okay, sir. So then how else should we remember it?
Just remember the oxidized species is the one that's on the, like in the data booklet, like just the way the notation is written in the data booklet. The oxidized species is the one that's on the left side. That is formed
Okay.
after losing electrons. ठीक है? It's losing electrons, and the reduced one is on the right side.
ठीक है.
ठीक है? That's the one that's formed after reduction. So remember it that way. फिर वो एक extra step बीच में नहीं आएगा कि बैठ के oxidation state नहीं calculate करनी होंगी. So ये वाला कर लेते हैं. So let's say let's use the Nernst equation. You might get a question कि जिसके अंदर they're very specific. For example, they'll talk about the Fe3 plus and वो जो ऊपर electrode था ना Fe2 plus electrode. And this value E naught was क्या थी value 0.77 volts. And they might give you कि जी एक reaction है जिसके अंदर this concentration was 0.15 mole per dm cube. And the concentration of Fe2 plus was 0.01 mole per dm cube. And they might ask you to find the E naught cell. अब E naught cell calculate करने से पहले the first thing is you would have to figure out the non-standard potential. Non-standard potential would be E is equal to E naught, which is 0.77 plus 0.059 divided by Z. Now Z is the number of electrons, which in this case is exactly 1. As a log of oxide species, the left one 0.15, or divided by log of reduced species, which is 0.01. अच्छा पहली चीज ना just to know that the Nernst equation is giving you the right answer, इसको वैसे predict कर लो कि the concentration on the right side is very low. If it's very low, that means the equilibrium would shift to the right side, and if it shifts to the right side, it's going to become more positive. ठीक है, तो E naught higher आना चाहिए. इसको calculate करके बताओ कि क्या value आ रही है.
Sir, 0.839.
0.839, so that's ठीक है, that makes 0.839, ठीक है, that makes sense. Let's just hold on 1 second. अच्छा फिर तो ये Nernst equation, ठीक है, we've got the Nernst equation. Predict how the value of the electrode potential varies with concentration. We're done with that. Construct redox equations, done that. Spontaneity, feasibility of the reaction. I mean, we're just going to talk about that for a second, and also about the relative group 17 halogens. ठीक है, you get a very almost always get a question on that. तो उसको कर लेते हैं कि क्या करनी थी दो चीजें. One was spontaneity, feasibility of a reaction, right? Now remember, for a feasible reaction, the E naught cell must come. It should be greater than 0. ठीक है, that's what we have learned, and that means okay, the E naught cell. How do you calculate the E naught cell? It's usually higher potential minus lower potential, but remember, the technical word is it's the reduction potential E naught minus the oxidation E naught. ठीक है, reduction gain of electrons वो higher होता है, and loss of electrons is the lower one. ठीक है, but technically it's reduction minus oxidation. Now, for this to take place, so sometimes what would happen is ये वाला केस आसान है क्योंकि ये तो आपने खुद ही determine किया ना who's going to gain electrons, who's going to lose electrons. You had a lower potential and you had a higher potential on one side. ठीक है, so this one gained electrons, this other one ended up losing electrons, right? तो higher minus lower करोगे तो definitely हमेशा positive आएगा. It's always going to come out to be positive. But इस पे आ जाते हैं कि in this notation, sometimes what would happen is they'll give you a reaction. For example, they've given you this reaction. KBr2 is coming in and displacing KCl, Cl in KCl, and it's turning into KBr, and it's forming Cl2. Let's say I want to figure out whether this reaction is feasible or not. पहला काम क्या है? पहला काम ये पहले तो आइडेंटिफाई करना है कि in this equation, what's happening? What are the two electrodes that are involved? You would notice that there's Br2 and Br minus 1. You'll just open the data booklet and you'll notice कि Br2 or Br का ना there's an electrode somewhere. This one. There's Br minus 1 turning into Br2, Br2 turning into Br minus 1. So there's this electrode which has a value of 1.07 volts. So पहले ना equation, if the equation is already made for you, what you're going to do is you're going to try and figure out कि भाई इस reaction के अंदर ना क्या चल रहा है, कौन से दो electrodes involved हैं. So it's Br2 plus 2 electrons in equilibrium with 2 Br minus 1. And the value is 107 volts. The other one is Cl minus 1 turning into Cl2. So open the data booklet, find the reaction that's happening at Cl2 plus 2 electrons, and it's turning into 2Cl minus 1, and the value is 1.36 volts. And so now in this case, since the reaction has already been made for you, तो आपने उस reaction को भी follow करना है. So figure out who's the one that's, by looking at the reaction, who's the one that's gaining electrons. The one that's gaining electrons is bromine, right?
Bromine.
So that's the one that's getting reduced, right? So that's the one that's getting
Yeah.
reduced, and this other
So it's
one is the one that. अच्छा, अब यहीं से पता लग जाएगा कि it's not feasible क्योंकि the potentials are suggesting something else कि जो higher potential होता है that's the one that gains electrons, right? So 1.36 volts must be the one that should be gaining electrons, but it's not. तो हम पहले तो इसको ही follow करें. Reduction E naught, that's 1.07. So that's 1.07 volts minus oxidation E naught, which is 1.36 volts. तो वो देखो तो value जो होगी that would come out to be negative. It's going to come out to be minus what, 0.29 volts.
जी sir.
Yes, so it's coming out to be negative, which is why the reaction is not feasible. ठीक है, तो दो तरीकों से, एक तो ये कि ये सारा ना इलेक्ट्रोड गिवन है, सब कुछ बनाया हुआ है, तो इसके अंदर तो it's always going to come out to be positive, क्योंकि you are the one who's deciding कि who gains electrons, who loses electrons, और आप गलत डिसाइड नहीं कर रहे, मतलब आप वही डिसाइड करोगे कि जी हायर पोटेंशियल है, this is lower potential, so you'll decide correctly, right? But if the reaction is already made for you, तो आपने फिर ना वो रिएक्शन को फॉलो करना है कि रिएक्शन में क्या हो रहा है. तो रिएक्शन के अंदर the wrong one is getting reduced. हमेशा it's the higher one. ठीक है, ये क्लियर है?
जी sir.
अच्छा, बाकी चलो बाकी था कि वो ग्रुप 17 का कर लेते हैं. Now group 17 halogens, उनका क्या होता है? You get a question on this very frequently. ठीक है, so halogens is starting with fluorine plus, बल्कि फ्लोरीन का मुझे याद नहीं है, Cl2 से कर लेते हैं. So it's Cl2 plus 2 electrons, and it's 2Cl minus 1, and we basically have to figure out which one is the reactive one. We've got Br2 plus 2 electrons. अच्छा, it's turning into 2Br. अच्छा, पेपर किस टाइम का, मॉर्निंग है या इवनिंग है? Oh, sorry, afternoon है.
Sir, it's an AM paper.
ठीक है. अच्छा, 2I minus 1. This is I think 0.54 volts. This is 1.07 volts, and this one is 1.36 volts. So which one हम दोनों तरीकों से करेंगे as oxidizing agents. Remember, the elements are the ones that act as oxidizing agents, and the first one, the top one, is the most powerful oxidizing agent because it has the highest E naught. Okay, since it has the highest E naught, so when you talk about the elements, then you have Cl2 that really likes to gain electrons. So it's a powerful oxidizing agent. So it's the one that's the most reactive. But on the other hand, when they're talking about the negative ions, तो negative ions ने तो electron lose करना है. So who's going to lose electrons? The one that has the lowest E naught. ठीक है. So when it comes to the elements, sorry, the ions, the halides, तो यहाँ पे bottom के ऊपर the reducing power increases, or you can say you have more powerful reducing agents when it comes to the negative ions.
Sir, and we'll explain it like this, right? Okay, if I minus has a lower E naught, it tends to oxidize, which means it reduces other substances, making it the best reducing agent.
हाँ. But इतना नहीं, you'll just get a 2-mark question on this. इतना detail में explain नहीं करना. What you just have to write is you're going to quote the values and you're just going to say that it has the lowest E naught, hence it has the greatest tendency to lose electrons. That's it.
ठीक है.
और इसके अंदर अगर वो elements की बात करें तो top ones are the ones that are the powerful oxidizing agents. ठीक है.
ठीक है.
Clear है ये? बस उसके अंदर make sure in your answer you quote these values. इनको copy करना है data booklet से.
Okay.
अच्छा, अब उसके बाद है कि the H2O2 fuel cell, nickel lithium ion rechargeable batteries. अच्छा, इसके अंदर you don't have to actually remember the cells. ठीक है. What you just have to know is कि I mean these cells are exactly, मतलब ये cell है, किधर है cell? I mean this is a cell, right? You could pick any two substances and it could act as a cell. One side would gain electrons, the other side would lose electrons. So you don't have to be very specific about, I mean, you don't have to remember the H2O2 fuel cell by heart. Is that clear? Yeah, nickel metal hydride cell, yeah, lithium ion rechargeable batteries. You don't have to remember. Huh?
What should we know about cells then?
What you Nick, repeat? Can you repeat the question?
Yes, sir. What do we have to know about the cells if we don't memorize like the reactions and stuff? Oh, okay.
Advantages of, I mean, ये तो example में दिया हुआ है, example this and this. So you don't have to. He's just asking for the possible advantages. ठीक है? तो ये सारे cells हैं. I mean, this is a cell. You can use this as a battery, right? You pick any two electrodes and that would end up as a cell. I mean, if you connect them together. So you don't have to be very specific about the reactions. और वो उसने question में दिया हुआ होगा. He might give you this cell. Okay, there's an Fe3 plus Fe2 plus solution over here, and this is over here, and they're connected, and a current is passing. ठीक है? तो उस बैटरी की ना पावर कैसे इंक्रीज करनी है. अच्छा खैर, the point is, what's the advantage? क्या advantage था ये हाइड्रोजन ऑक्सीजन फ्यूल सेल का?
So the only product is water, so it's not a pollutant. Also, you can get oxygen from the environment.
ठीक है. One is that it's also renewable. ठीक है. और बाकी cells अगर तो if you're talking about the hydrogen oxygen fuel cell, then it's no pollutants produced. In it, water is the only byproduct. A disadvantage could be that you have gases which are difficult to store. So just one, maybe just remember that renewable, no global warming, etc. ठीक है, उस तरह की बातें. अच्छा, केमिकल इक्विलिब्रियम को स्किप कर लेते हैं अभी. हम कर लेते हैं ये सारा हमने किया था. अच्छा, this one, let's just quickly go through reaction kinetics. So you've got order of reaction, rate constant, and half-life of a reaction and rate determining step. ठीक है? Now there are going to be 3 methods जिसके अंदर ना आप कर सकते हो, figure out कर सकते हो. If you have any reaction, let's say there's X reacting with Y and it's producing Z. Now the speed of the, पहले तो what is rate? rate is any change with respect to time. Laboratory के अंदर it's any change with respect to time. कि कितनी तेजी से वो change हो रही है. ठीक है, that's what rate is. And technically it's change in concentration with respect to time. So mathematically speaking, it's mole per dm cube per second. ठीक है, लेकिन rate could be anything. It could be a color change, it could be a mass change, it could be any change that's happening with respect to time. अच्छा, अब rate की value positive भी हो सकती है, negative भी हो सकती है. I mean, depends on if you're finding rate based on reactants. The reactants are always decreasing, so it's the gradient of that change. But it could be it's the gradient of the change if the mass. तो आप वो change को ना plot करो graph के ऊपर with respect to time. So let's say I have this reaction. I have Mg plus HCl and it's turning into MgCl2 plus H2 gas. अब इसमें बहुत सारी changes हो सकती हैं. It could be the mass decreasing because H2 gas is being released. तो अगर मैं mass को plot करता हूँ तो mass का graph किस तरह का आएगा कि mass का graph constantly decrease होगा. And eventually at a certain point it would become constant. ठीक है, let's say यहाँ से ना it's becoming a constant. ठीक है, constant का मतलब है the reaction has stopped. So this is.
So we can also measure the volume of H2 produced, right?
हाँ, तो mass decrease हो रहा होगा. You can measure any change, volume of H2 produced, so that would be increasing, and then it would become, at a certain point, it would become a constant. Okay, so that's.
But sir, then isn't that kind of misleading because in one graph the initial rate is negative and in the other one it's positive? So do we only consider the magnitudes?
You always consider the magnitudes, not the direction of the change.
ठीक है.
ठीक है. So if we plot the gradients, तो mass का जो gradient होगा वो negative आ रहा होगा initial. इसका जो gradient होगा वो positive आ रहा होगा. ठीक है. So you don't look at the sign of the gradient, negative or positive. You're going to look at the value, the magnitude of the gradient. Okay, that's the thing. And the other thing is you always look for the initial rate. Okay, rate always comes to zero. It's a variable with respect to time. So if you're doing some comparison, you always measure the initial rate. So always focus on the initial rate right at the beginning, and you'll be asked to draw gradients for that. The way to do that is just make 2 points very close to each other right at the start and place a line over there. So that's how you're going to draw gradients. Gradients can vary a lot, especially initial. There's nothing to. It's very hard to make a tangent at the end of a line. For example, if I make this line over here, this could be the gradient, or maybe this could be a gradient. So it could vary a lot. So what you should do is you should make 2 points initially and then pass the line through those 2 points. Okay, so what now the gradients would be varying a lot. So the thing is that you always measure initial rate, and rate is change with respect to time. So you could be plotting any change with respect to time and ignore the fact that it's negative or positive. अच्छा, उसके बाद ये कि how do you measure the order? Now, for example, in this reaction, बल्कि पिछला वाला ही कर लेते हैं, x plus y and z. नीचे दोबारा लिख लेता हूँ. So I've got this reaction x plus y and it's reacting to produce z. इसके past papers भी करेंगे, ठीक है. अच्छा, x plus y and it's turning into z. So the rate is dependent on the reactants. It's usually not dependent on the products. It's dependent on the concentration of the reactants, which in this case would be X, and the other one would be Y. But what you don't know is how is it dependent. That's going to be A and B. Okay, that's the relationship. That's going to give you the order of the reaction. And if you bring in a constant, you'll get rid of the proportionality sign. That would be your rate constant. So that is going to be your rate constant.
Also, sir, isn't it the coefficients of the uh, molecules doesn't actually matter, right? It doesn't determine the order.
It does kind of matter. I'll just go through the mechanisms and then I'll explain. Okay, it would actually kind of matter in a certain case. Okay, your statement is also true, but it would kind of matter. So let's start with the first thing, and that is how do you figure out the order of the reaction? What is the order of the reaction? It's the exponent. It's literally the definition is that it's the power of the concentration of a reactant in a rate equation. That's it, or the exponent of the concentration of a reactant in a rate equation. So how do you calculate orders, and why do you have orders? For example, we say that rate is dependent on the concentration of the three orders. Rate is dependent on the concentration of X, and the power is 1. That means it's direct proportional, that if you increase the concentration of X, then the speed of the reaction would increase. Proportionally, if you double the concentration of X, then the rate of the reaction would also double. So that's order 1. That means it's directly proportional. Okay, this one is this one is directly proportional. Then you have rate proportional to the concentration of X, but the order is 2. Now, see, Sarah, so this one, rate is proportional to the concentration of X, and the order is now 2. That means that rate is very sensitive to the concentration of X. Like if you double concentration, the rate would quadruple. So you double the concentration of X, and the rate quadruples. Or vice versa, or what you can also say, if you triple the concentration of X, the rate would become 9 times. If you quadruple the concentration of X, the rate would become 16 times. So that means the rate is changing a lot. You make a small change in the concentration of X, and the rate is affected by a larger margin. So that's order 2. And then you have rate is proportional to the concentration of X, and the power is 0. That is order 0. That means no matter what the concentration of X is, anything to the power 0 is 1. That means the rate would remain unchanged. So there is no effect. No matter what you do, the rate is not going to be, it's not going to be affected by this. So one by one, ठीक है? अभी पास पे भी करेंगे, हर type of question बीच में include करेंगे. So first thing, how would the graphs look like? Okay, that's the first thing. That's the first way of finding the order of the reaction. So order 0 is the graph for order 0. The graph for order 0 is if you plot the graph of order of X with respect to time. So with respect to time. Now in any reaction, the reactants, they decrease, their concentration decrease, they get used up. And if they're getting used up, then the concentration would basically go to 0. But in an order 0 reaction, if rate of the reaction is not really dependent on the concentration of X, तो उसमें क्या होता है, उसमें the graph is a straight line. ठीक है, that means the gradient does not change. The gradient is the rate. It does not change. Usually reactions slow down as time proceeds, but in order zero reaction, the reaction is not going to slow down. जिस speed से वो decrease हो रहा है, उसी speed से it would keep on decreasing, and it would just end up to zero. मतलब वो एक ही speed से ना reaction चलेगा, and that's it. Because the concentration of X, even if it's lower, it's not going to affect the rate of the reaction. ठीक है, और इसके अंदर क्या होता है, इसके अंदर there's a thing called half life. The half life always decreases. Half life is the time taken for the concentration to decrease by half. So the half life फिर ये अगला half है. So the half life constantly decreases. फिर उसके बाद दोबारा half हो रहा है. How much time it takes? So you can see that फिर उसके बाद दोबारा half हो रहा है. So you can see that the half life continuously decreases. This is your first half life. This is your second half life. This is your third half life, and so on. So the half lives are constantly decreasing, and they are decreasing by a factor of half. अब फिर इसी तरह कि you've got, इसी को कॉपी कर लें. अच्छा, फिर इसी तरह कि you've got order 1. अच्छा, अब order 1 में क्या difference होगा? Order 1 would be कि now rate is directly proportional. Okay, if the reaction proceeds and the concentration decreases, the reaction would slow down. So in this, what happens is okay, the half-life remains constant, which means that if you're starting at this point, the time it takes for the reaction concentration to decrease by half is this one. It would remain उसके बाद दोबारा half होने, that still remains the same value. Then it's decreasing by half again. Then it's decreasing by half again once more. So in this case, the graph is going to be it's going to be a curve. It's going to be a curve with decreasing gradient. Okay, so half-life remains a constant. So that's your first half-life. So that's your second half-life. Then you have your third half-life. So all your half-lives are a constant in this case. So there is constant half-life, rate decreases proportionally. The gradient decreases proportionally. वो उसके साथ साथ ना decrease होता जा रहा है. Why? Because the rate is dependent on the concentration of X. So as the X gets used up in the reaction continuously slows down. ठीक है, eventually वो end में जो line है ना, it's almost a flat line. ठीक है, clear है ये?
जी sir.
और फिर आपके पास you've got order 2. ठीक है, order 2 is order 2 जल्दी से बना लें. order 2 में कि वो X की concentration अगर change होगी ना, तो rate कुछ ज़्यादा ही change हो जाएगा. Rate would decrease by a lot. It's proportional to X concentration but power 2. So a minor change in the concentration of X would change the rate. So let's say this is your first half-life. तो second half-life का जो time होगा ना, वो double हो जाएगा. So that's your second half-life. Third half-life का जो time होगा वो उससे भी ज़्यादा हो जाएगा. So it's going to be, this is your third half-life. Fourth half-life, the time would increase even more. तो reaction जो है वो कुछ ज़्यादा ही slow होता जाएगा. ठीक है, so it's going to take a longer and longer time ऐसा क्या होगा? And anyways, the half-lives would be double the previous half-life. That's the first half-life. That's the second half-life. This is the third half-life. Every time the half-life continuously increases. So it continuously increases. अच्छा ये half life method है. तो ग्राफ बना होगा. अच्छा इसके अंदर what has to be done is if a reaction has multiple reactants, so how do you know that the graph, well, for example in this case we've got two reactants, we've got X and you've got Y. So how do you know that the shape of the graph or the speed with which X gets used up, Y isn't, मतलब वो जो rate है उसका जो gradient है, that would be affected by Y. So how do you make, what changes would you make to the solution so that Y doesn't play a role? मरीम क्या करना होगा?
Sir, can you repeat that?
नहीं मैं इसका सिर्फ ये बता रहा था कि if you're plotting the concentration of X and the speed with which it's decreasing in the reaction, right? तो वो जो rate है, ये जो gradient है, that is not just dependent on X, it's also dependent on Y as well, right? So how do you ensure that Y doesn't play a role?
Sir, you keep its concentration constant.
And how do you keep it constant? You add it in excess. ठीक है, उसको large excess के अंदर add करते हैं ताकि even if the reaction starts and Y gets used up, तो अगर Y use up भी हो जाएगा तब भी उसकी concentration almost same ही रहेगी because you've added too much of Y. Is that clear?
जी sir.
अच्छा फिर ये कि second step, that's the mechanism. ठीक है, let's move towards mechanism. Okay, how do you, अच्छा now how is the order determined by the mechanism of a reaction? Now remember, slow step is the rate determining step. Is your rate determining so that's your rate determining step. अब इसमें क्या होगा mechanism के अंदर? It's a rate determining step. Why is the rate determining step? For example, there's a tertiary halogenoalkane. उसके अंदर पहले step में होता है the carbocation is formed. So Br minus 1 breaks off, and then the second reactant, which is the OH ion, it comes in and bonds with it. तो COH बन जाता है, ठीक है? अच्छा, that's the mechanism, and you've got two steps to it. The first one is the slow step. The second step is the fast step. अब इसमें ये ख्याल रखना है कि the rate is only dependent on the slow step. I mean, there are two reactants. One is this one, and the other reactant is OH minus 1. Okay, they're both involved in different steps. So rate is, or it should be dependent on the two reactants, but in this case, it's only dependent on the halogenoalkane concentration. So this is one reactant, and the other one, जो fast step वाला होगा ना, उसका जो order होगा ना, that's going to be 0. Okay, that one is going to be 0. And the reason it's going to be 0 is okay, no matter how much you increase the concentration of OH, and the overall speed of the reaction is not going to be affected if the fast step speed increases. If this takes 100 seconds,
Sure.
yes.
So what about the carbocation concentration? Do we not consider that?
No, but that's an intermediate. ठीक है? I mean, its concentration is dependent
Oh,
on the
yeah.
on this constant. So, but even if we write the carbocation intermediate, we're basically talking about this one. ठीक है? अच्छा, so you've got this. You've got the orders, and remember, it's always dependent on the slow step. Ab Mayim, that thing about the coefficient not being an issue over here. ठीक है? Remember कि अगर मैं इस equation में ना, the coefficient is an issue for the slow step. अगर इस equation में ना there were two CH3Brs, right? तो ये square हो जाता. Do you get my point?
Yeah, okay.
ठीक है? So it's not dependent on the coefficient of the actual equation. It depends on the coefficient of the slow step equation. अच्छा, तो mechanism से ना order निकालते हैं कि how do you find orders? Let me open a worksheet. उसके we'll try and find the orders with respect to mechanisms. 1 second. अच्छा, mechanism वाले पहले क्वेश्चन कर लेते हैं. Just a second. So ये वाला कर लेते हैं, ठीक है? So if you've got this reaction that's happening, और इस reaction में ना the three, I think over here. अच्छा, there's chlorate 1 ions, iodide ions, and OH ions. ठीक है? Based on this is the reaction that's happening. Based on what they've given us, okay, there's chlorate 1 ions, iodide ions, and there's aqueous alkali. So we're assuming there's ClO minus 1 ions, there's I minus 1 ions, and there's aqueous alkali, which is OH minus 1 ions. These are your three reactants. Okay, so the rate is dependent on these three reactants. We don't know how it's dependent on these three reactants. So there is ClO minus 1 that's playing a role in the first step, OH minus 1 coming in the third step, and I minus 1 coming in the second step. Again, so first one is the slow step. If the first one is the slow step, then the rate would be dependent on the concentration of ClO minus 1, and it would be dependent on the concentration of H2O as well. If it's the first step. So water is also playing
But
a
sir,
role.
if water is intermediate, do we still consider it?
But right now it's not an intermediate. Your first step में water आ रहा है. I mean, so you need water at the start of the reaction. So it's not an intermediate. Intermediate वो चीज
Okay.
होती है जो बीच में बनती है. ठीक है? Over here, water is acting as a catalyst, I think, because it is getting reformed, but it's not an intermediate. So in this case, if the first step is the slow step, then the rate would be dependent on the concentration of ClO minus 1 and the concentration of H2O. Okay, so that's it would be order 1 with respect to these two, and it would be order 0 with respect to I minus 1 and order 0 with respect to OH minus 1 as well. अच्छा, what if दूसरा कर लेते हैं. अच्छा, what if the second step was the slowest step? तो रेट किस पे डिपेंड करता है? रेट would have depended on I minus 1 concentration, and it would have been dependent on the HClO concentration, right? Now HClO is an intermediate because this HClO is itself dependent on the concentration of ClO minus 1 and H2O. So when we say that rate is dependent on the ClO concentration, we're not actually, what we mean is that rate is indirectly dependent on ClO minus 1 and H2O concentration. ठीक है, Mariam, is this clear?
Yeah.
तो इंटरमीडिएट्स नहीं लिखने, ठीक है, उन इंटरमीडिएट्स को कैंसिल आउट करके यू हैव टू राइट द ओरिजिनल वैल्यूज, ठीक है, कि ओरिजिनल कौन सा रिएक्टेंट है. एंड सिमिलरली अगर थर्ड स्टेप स्लोएस्ट होता, ठीक है, तो रेट किस पर डिपेंड करता, रेट वुड हैव डिपेंडेड ऑन दीज टू, HIO concentration and OHN concentration. फिर पता लगता है कि जी HIO जो है ना, that itself is dependent on these two. तो HIO को काट देते, आप लिख देते कि rate is dependent on I-1 concentration and HClO concentration, right? Because HIO is made from I-1 and HClO. और फिर पता लगता है कि HClO के ऊपर अगर रेट डिपेंड करे, HClO itself is made from ClO-1 and H2O. So HClO would be cut out and you'll have ClO-1 and H2O written in its place. Clear है ये?
जी sir.
अच्छा, identify a step which involves so forget that, एक और कर लेते हैं इस तरह का कि so let's say, अच्छा, so there's this reaction that's happening in hydrogen peroxide and iodide in an acid solution. So I think there's H+1 involved as well. Bottom वाले से start करते हैं. Let's say the step 4 is the slow step. उसने खैर पहले ही कह दिया कि step 1 is the rate determining step. I'm just going to assume that just for the sake of the question, कि let's say step 4 is the slow step. तो क्या होगा ये कि rate would be dependent on OHN concentration and it would be dependent on H+1 concentration, right? And then you'd figure out कि जी ये जो OH ion है ना, that's वो तो खुद I-1 और उस पर depend कर रहा है. So rate would be dependent on I-1 and HIO. फिर पता लगता है कि HIO खुद इन दोनों पे depend कर रहा है. So you'll get rid of HIO and you'll add H+1 and IO-1 in its place. And then you would have figured out कि if rate is dependent on IO-1, तो वो तो खुद I-1 और H2O2 पे depend कर रहा है. So you're going to put in I-1 and H2O2 in its place. अच्छा, जब सारों को sum up करोगे पता लगेगा कि rate, if step 4 is the slower step, rate would be dependent on H+1 concentration twice. So that's squared. I-1 concentration be 2 times that squared and you'll have H2O2. ठीक है, तो यहाँ से order 2 आ गया. Is that clear?
जी sir.
और अगर step 1 जो इस question में step 1 slowest होता तो rate would just be dependent on these two. Coefficient वाला भी मैं कर लेता हूँ, एक सेकेंड. अच्छा, इसके क्वेश्चन को करना किस तरह कि कहाँ गया. अच्छा, remember कि you'll get different orders based on which one you select as the slowest step. Now the question will use experiments, they'll use graphs etc and you'll figure out the order. तो आपने बस मैच करना है. How do you figure out which one is the rate determining slow step? आप सारों के हिसाब से ना orders निकाल लो और जो orders आपके साथ मैच कर रहे हैं ना, that's the one that's the slowest step. ठीक है, तो let's एक और मैं वो देख लूं कि अच्छा, sometimes you'll be asked to to make your own mechanisms. ठीक है, सही क्वेश्चन है. This is now frequently being asked. You're being asked to make your own mechanisms. So NO and F2 reacting to form NOF, and उससे क्या है, the rate is first order with respect to NO and F2. So you have to think of your own mechanism. तो इसका mechanism वो खुद बना लेते हैं. Let's make 2 steps, 3 steps. जितने मर्जी steps बनाओ, ठीक है. We don't know what the mechanism is, so it's up to us. So what I'm going to do is I'm going to react NO with F2, and it let's say it takes one of the F, और एक F produce हो गया, and then this other F goes and reacts with the other NO, and at the end of the day you get 2 NOF. Okay, so let's say this is my mechanism. Now, if this is my mechanism, uh, तो उससे क्या है कि first order with respect to NO and F2. So let's say this one is the slow step. This one is the rate determining slow step. So my rate would be dependent on the concentration of NO and F. So rate would be dependent on the concentration of NO and it would be dependent on the concentration of F. फिर पता लगता है F तो intermediate है, that's made in the previous step, and F itself is dependent on the concentration of F2 and NO. अच्छा, so if I take the second step as the slow step, then the problem is going to be that NO जो है ना, that would come twice. It would have order 2. And he was very specific that the rate is first order with respect to NO and F2. So the second step is not going to be the slow step. Let's try the first one. First one is going to be the slow step. So the rate would be dependent on just NO and F2. It would just be dependent on NO and F2. That's it. So
There's,
that would
since
be the
people
right one.
make different mechanism equations, is there like room for difference in the marking scheme?
Can you repeat?
So
But
since
in this
people
case,
can
there's a lot of room for
different,
difference as long as
yeah,
in this case, there's a lot of room. They'll accept a lot of things, uh, as long as it makes some sense. Like it should just make some sense. That's it.
yeah,
It's probably good because they're probably looking for this fact that you're able to figure out which one is the slow
yeah,
step.
okay.
Okay? And you're able to determine the orders correctly. So mostly the 2 marks are probably for that. ठीक है, not really for the mechanism. अच्छा क्या इस तरह का ना कोई just trying to find
Sir,
ठीक है
how
maybe
much of AS inorganic have to know for P4? So like group 2 oxide reactions, group 17, all of that.
basically you would have to know all of it, but the thing is the question would mostly be focused on A2. I mean you'll get small tiny bits on AS. ठीक है, so the question would be like mostly focused on A2. लेकिन बीच में there would be tiny things, small things coming from AS. अच्छा let's अच्छा final वो third तरीका कर लेते हैं. Let's just sum this up. So there's mechanism, there's the graphs, and the third one is the experimental method. Yeah, that's the third one. So that's of figuring out the order of the reaction. So that's your experimental method. Experimental method में क्या करते हो? Let's say there's a कहीं table given है. Just a second, let me find a few tables. अच्छा, let's say this is the इसको copy कर लेते हैं. So you've got this table and you've got a reaction, and that's not the mechanism. Now the way you're going to find the order of the reaction is, and the first thing is the easy method. I mean, there are going to be two types of table. There's going to be an easy table and there's going to be a slightly more difficult table which has to be solved. Uh, you're going to find two experiments in which the concentration, you've got two reactants. So we are looking for what would be the order with respect to NO. So we don't know what A is, and we don't know how it's dependent on the concentration of O2. That's my other reactant. We don't know what B is. So we're trying to find we're trying to find A and B. Now, in this case, you're going to try and find two experiments where the concentration of one of the reactants, like over here in experiments 1 and 3, O2 concentration is constant, so that is not going to be a factor. What's happening to the concentration of NO? That's decreasing by half. Okay, that's becoming half. In this case, it's becoming half. It's going from zero point 0.1 to 0.05. So you're going to find experiments where one of the reactant concentration is only changing and the other ones are constant. So what happens to the rate of the reaction? Uh, how do you figure out the factor? Okay, इस number को take this number and divide that number by 3.5. You'll get the factor, which in this case is I think 1 by 4, right? Bari me?
Yeah.
So that's order 2. That's order 2 square की relationship है, ठीक है? So you found A as being equal to 2. Now what do you do? So that's one. And how do you explain this in your question? You're going to be very specific that if you're going to write that compare uh, experiments 1 and 2, experiments 1 and 3. You have to be very specific, and then you have to state that NO concentration decreases by half. And your rate it decreases by 1/4. So hence it's order 2 with respect to NO. NO concentration. Be very careful. It's NO's concentration. Anyways, that's what you're going to write. But what about the other one? How do you figure out O2's concentration? Now, to figure out the order with respect to O2's concentration, you want two experiments in which O2 is changing, but NO is remaining constant. So it's going to be experiments. It's going to be experiments 2 and 3. Okay, NO remains constant, so that's not a factor, and the concentration of O2 decreases by half. ठीक है, तो 1 by 2 हो रहा है. And the rate of the reaction also I think decreases by half. यही हो रहा है ना? ठीक है, remember factor के साथ निकालना है, divide the smaller. So that's order 1. So O2 के respect से it's order 1. Clear है ये? तो
जी
इसमें
sir.
भी इसमें भी क्या करना है? You have to ये इसी तरह explain करना है. Comparing experiments 2 and 3, O2 concentration decreases by half, and the rate decreases by half as well. So that's directly proportional. That's order 1. Anyways, that's one way to figure out the order of the reaction. But then there are certain graphs, certain tables where this is not that simple. कोई अगर मिल जाए एक second.
फिर उसमें सिर्फ वही करते हैं ना कि you have to compensate for the other reactant and then
हाँ, मतलब
you
for example this one, right?
yeah.
I mean, we're going to compensate for the other reactant, but the mathematical way is कि if you look at these two experiments, it would be kind of easy to figure out the order with respect to NH3, right? Because if you look at experiments 2 and 3, if you compare these two experiments, then you would notice that ClO minus 1 is constant. That's not changing. Whereas NH3 में क्या फर्क पड़ रहा है? NH3 is double हो रहा है, ठीक है? NH3 is changing, it's into 2. And this, I think, the rate में क्या फर्क पड़ रहा है? Rate is into 4.
It's times 4.
So the order with respect to NH3 is 2. ठीक है? Square की relationship है. So we figured out the order with respect to NH3. But then you have an issue, which is कि if you go and look at the table again and you want to figure out the order with respect to ClO minus 1, so you want ClO minus 1 to change and you want NH3 to remain constant, but uh, it is not remaining constant anywhere. तो अब क्या करेंगे? What you can do now is कि you can pick any two experiments but the CLO -1 should change. So let's say pick experiments 1 and 2. अब या तो वो compensation वाला part बीच में डाल दो, ठीक है? But that could kind of be confusing. Mathematical तरीका ये है कि what you can do is take experiment 1. You've got the rate equation. The rate equation is CLO -1 concentration. You don't know what the order is, but for NH3 you know the order, and the order is 2. ठीक है? तो वो rate equation थोड़ी बहुत आपको पता लग गई है, ठीक है? You've gotten some idea of what the rate equation is. अब इस केस में ये रेट है आपका. You've got CLO -1 concentration and you have NH3 concentration. What you just need is X. इसके अंदर दोनों equation substitute करो. Start with the first one. The rate is 0.256 and CLO -1 is 0.2 power X. ठीक है, and NH3 is 0.1. Even this is X. 1 second. ठीक है, so I've substituted experiment 1 values into this. अब experiment 2 की values put कर लो. It's going to be 2.05, right? And it's 0.4 power X. This is going to be 0.2 power 2. So I've substituted experiment number 2 values. Clear है भाई? ठीक है, hopefully you have done this correctly. So दोनों values substitute कर लो, you get two equations. You just have to solve them. इन दोनों को divide कर दो, इन दोनों को divide कर दो. Proportionality का sign जो है ना, that would become, वो cancel out हो जाएगा, it would equality आ जाएगी. And you just have to find the value of X now. So this is going to be half 0.2 divided by 0.4, that's half to the power X, into, I think, half squared. 0.1 divided by 0.2, that's half. 1 by 2, and that would be squared. What is 0.256 divided by 2.05?
It's 0.125. So 1/8.
So 1/8 कर लेते हैं, ठीक है? 1/8. अच्छा ये X है, वहाँ पर इसको 2 करो. That's X. और remaining क्या है कि you've got X निकाला ना, half square को तो ले जाओ. What would happen? कि इसको 2 square से multiply करना होगा, ठीक है? So what's going to happen is कि if you take it to the other side, it's going to be
It's 1.
क्या आ रहा है?
1.
ठीक है, you're getting 4/8, and that would be the half to the power half X आ गया, ठीक है? And X is then obviously equal to 1. Clear है ये कि if you don't find any two experiments in which वो जिसको आप find करो, that should change, the other one should remain constant. But if the other one is not remaining constant, you can do this. Substitute the two experiments in the equation.
Sir,
And
if we use the computation method, can we also explain that in the working, or should we use this instead?
you can explain that in the working. For example, in this case, it would be kind of pretty hard, I think. मतलब कर लेते हैं, इस केस में भी actually हो जाएगा कि वो NH3 का फैक्टर, NH3 को पहले फैक्टर इन कर लेते हैं, ठीक है? Which is 0.122, it's doubling. So rate कितना होना चाहिए? 4 times होना चाहिए ना. So it would become what?
1.024.
So 1.024, right? तो ये NH3 का जो फैक्टर है ना, वो तो मैंने एक्सक्लूड कर दिया, ठीक है? That's now gone. तो ये जो बाकी डबल हो रहे हैं, किसकी वजह से हो रहा है? That's because this is doubling, so that's order 1.
Yeah.
ठीक है, तो ये दूसरा मेथड है, लेकिन वो थोड़ा सा कंफ्यूजिंग हो सकता है. So it would be a lot
ठीक है.
easier if you just do this. तो ये 3 मेथड्स हैं, बस इसको देख लेते हैं कि किधर हमारा सिलेबस का. अच्छा, so there are 3 methods. Table, और इसमें वो मैं ऐड कर दूं कि, और फिर वो एक एक्सपेरिमेंट की वैल्यूज पुट करके ना, you have to find K usually, and you have to find the rate, the units for K as well. And the units for K, वो कैलकुलेट कर ही लोगे, उसमें इतना मसला नहीं होना चाहिए. So there are 3 methods, और जब एक दफा ऑर्डर पता लग जाए ना, it's easier to identify the mechanism कि which one. इसने आगे पूछा होगा probably mechanism का question. हाँ वो ये पूछ रहा है ना, तो कि which one is the slow step? तो आप देखोगे first one slow है, second slow है, third slow है. Every time you're going to get different orders. And based on what orders you get and based on the orders that you have found using your experiment, हमारे orders क्या आए थे? इसके 2 आया था, इसका 1 आया था, ठीक है? तो आप फिर मैच करोगे कि which one is going to be the slow step. तो वो फिर ट्रायल एरर मेथड होगा कि बॉटम वाले को सिलेक्ट कर लो, सेकंड वाले को सिलेक्ट करो, फर्स्ट वन को सिलेक्ट कर लो,
ठीक
एंड
है.
फाइंड आउट कि किसके अंदर ना वो वाले ऑर्डर्स आ रहे हैं जो आपने एक्सपेरिमेंटली कैलकुलेट किए हैं. अब बाकी है कि multi-step device is a suitable experiment technique for studying the rate of a reaction from given information.
This
तो
is paper 5, right?
हाँ, क्योंकि इसमें भी आ जाता है क्वेश्चन. फॉर एग्जांपल इसमें there would be questions will be asked to devise an experiment. One second. And you get big questions on this. ये just there. ठीक है, lots of lines. So it's saying the reaction between hydroxide ions and bromoethanes first order with respect to OH and first order with respect to Br minus CH3Br. So दोनों के respect से it's first order, dependent on both. Suggest a practical method that would confirm that the reaction is first order with respect to OH ion. So you're investigating OH ion. So how do you keep CH3Br constant? तो एक तो ये बताना है कि एक point तो ये होना चाहिए कि add CH3Br. I mean, this should be part of the add CH3Br concentration in large excess, so that its concentration hardly changes in the reaction and it doesn't play a role. So your method should include details of measurements that would be made in order to calculate the rate of the reaction. You should include a method of presenting the results to show. Acha, pehli cheez, how do you figure out the rate of the reaction? Well, the rate is changed with respect to time. So how would you?
Can we do the color because Br minus is being produced?
But that's colorless. Br2 is the one that's red brown. Uh, so it has to do with OH ions. Okay, what you can do is you can measure the pH. Okay, and from pH you can measure the OH ion concentration, and you can figure out how fast that is changing. So you can plot a graph. OH ion concentration with respect to time.
Sir, do we have to mention how we'll measure the pH?
नहीं बस I think pH meter. वो देख लेते हैं marks. You just use a pH meter or the pH meter would be fine. You measure the pH, so plot OH concentration with respect to time. So OH concentration would obviously decrease. And if it's order 0, तो फिर ये graphs आ जाएंगे जो 3 graphs ही plot किया है, depending on the shape of the graph. How does it decrease? ठीक है, if it's order 0 तो वो फिर decrease होगा, speed would not change. Order 1, if it decreases, it slows down. The speed slows down. So it's going to be order 1 if the half-life remains constant, and if the half-life doubles, that means it's order कौन सा 2 होगा. Also, you should include a method of presenting the results to show that the reaction is first order with respect to OH minus 1 ions. तो आपने बस pH measure करना है different time intervals के ऊपर. इसका बल्कि 4 mark का it's लिखने की बजाय just कौन सा W19 QP42, just 1 second. वो सारे marks की distribution देख लें. PDF. This is question number 2. अच्छा ये उसने किया हुआ है. Excess of CH3Br, that's 1 mark. Several experiments. You can either do several experiments. We didn't do several. Alternative approach. We're doing this one. We did one experiment with a known initial OH ion concentration. Control variables रखने थे कि temperature etc. ठीक है. And we measure time. We plot the OH ion concentration with respect to time. How do you measure fine OH ion concentration? You can either titrate or by using a pH probe. So a pH meter would be fine. And using that pH meter, you can plot a graph of OH versus time and look for constant half-life, because they already told us that it was order. They already told us that it was order 1. ठीक है? Is that clear?
जी sir.
But this the only thing that was missing was control variables. Mention the control variables. And so what's this other method? The other method is okay. What you're going to do is you're going to plot several graphs. And there's this other. What other ways is he doing? Okay, there's another way that he's doing is that uh, he's trying to figure out the Br minus 1 concentration by adding Ag plus 1. So that would give you a precipitate of AgBr. Okay, so that's another way that he's doing is because there was Br minus 1 involved, and and he's also titrating it. So that's another alternative method that you can at every time interval you can stop the reaction and you can titrate the OH ion concentration, figure out the OH ion concentration. For example, by adding HCl. ठीक है, ये clear है? pH probe was probably the easiest. और वो OH versus rate. ठीक है, क्या आप इसमें वो why is he doing several experiments? Let's say OH ion concentration is 0.1 mole per dm cube in the first experiment, and you double it 2.2 mole per dm cube. So if it's order 1, then the rate would double as well. तो आप वो टाइम देखोगे, और टाइम रेट क्या होता है? रेट इज proportional to 1 over time. So is it taking less time or is it taking more time? So you're just going to measure the time और वो निकालोगे. इस तरह टेबल नहीं बनता. The tables that we
Sir,
make.
how would we find the initial rate? What's the way we do that?
See, whenever you have a graph, कि इसके अंदर दो चीजें कर सकते हो ना in this. Like we did this one, right? So we're trying to figure out this one. You can do two things. One is you can use rate as being 1 over time. ठीक है? How do you measure the initial rate? Initial rate, you start the reaction, right? And change with respect to time, right? And you have to stop the reaction at a very predetermined mark. ठीक है? There has to be a mark set where you stop the reaction. Okay, how much time does it take for the reaction to start and reach that particular point? Now, what is that point? How do you figure that point out? So, वो आपकी मर्जी है कि, for example, you're calculating OH ion concentration, right, using a pH probe. What you could do is you can set it कि जी OH ion concentration अगर शुरू में 0.1 mole per dm cube है ना, so how much time it takes for it to, let's say, decrease to 0.01 mole per dm cube, right? So you can put a mark over there कि कितना टाइम लगता है उसको इस stop mark तक पहुंचने में. If it takes a longer time, then the reaction is slow. If it takes a smaller time, then the reaction is fast. तो एक predetermined mark set कर सकते हो, exactly the way we can do over here.
Sir, can we also do this? We have different initial concentrations of OH minus, and then we do the reaction, we plot OH minus against time, then we do the initial tangent for each cheese, then we get the initial rate, and then we plot rate against OH minus, and then if we get directly proportional, then it's order 1.
नहीं, वो exactly वो भी कर सकते हैं. You can plot the graphs, ठीक है, every time change the OH ion concentration. अगली दफा जो graph होगा ना, that would be steeper, ठीक है, if you increase the concentration of OH ions. So the graph would be steeper and that would give you a faster reaction. तो tangent पे draw कर लो initial rate, ठीक है. So one is this one, or so that is one, ठीक है. Note this down. That is one way, ठीक है. The other way is कि आप पूरा ग्राफ ना बनाओ, आपने बस ये एक प्री डिटर्मिन्ड मार्क सेट किया हुआ है कि ये जो मार्क है ना, मतलब दिस इज योर स्टार्टिंग पॉइंट t0 to 0, दैट्स व्हेन यू मिक्स थिंग्स अप, ठीक है, व्हेन यू स्टॉप। तो आपने ये मार्क सेट किया हुआ है एंड रेट इज प्रोपोर्शनल टू 1/time. Anyone who reaches that mark first, he wins. That's the fastest. Do you get my point?
Yeah.
ठीक है, so in that case you don't have to plot the entire graph. आपको पता लग जाएगा, आइडिया हो जाएगा कि which one is fast, which one is slow. कि अब वो मार्क किस तरह सेट करना है. फॉर एग्जांपल इस रिएक्शन के अंदर यू कैन सेट अ मार्क के जी whoever makes 10 cm cube of H2 first. So if the reaction is slow, it's going to take a longer time to make 10 cm cube of H2. If the reaction is fast, it would take a shorter time to make 10 cm cube of H2. तो आपको वो पूरा H2 का ग्राफ प्लॉट नहीं करना पड़ेगा. And you'll get the idea of rate. Is that clear?
Yeah.
So that's another way. और थर्ड तरीका था कि आप एक ही ग्राफ बनाओ, उसको पूरा बनाओ टाइम के रिस्पेक्ट से कि हाउ इज द रिएक्टेंट डिक्रीजिंग, और उसकी शेप फिगर आउट करो, ठीक है, एंड यू फिगर आउट द हाफ लाइफ मेथड, ठीक है, उससे आप ऑर्डर निकाल लो. दैट्स द थर्ड मेथड. ठीक है, तो रिमेंबर कि ये वाला वैसे यूजुअली कोई नहीं करता, ये वाला जो मेथड है ना जिसके अंदर आप पूरा ग्राफ बनाते हो, क्योंकि पूरा ग्राफ बनाने की जरूरत नहीं है. वी जस्ट वांटेड टू नो कि इज द रिएक्शन स्पीडिंग अप और नॉट. ठीक है, is it is it speed doubling or not, is it speed quadrupling or not, we just need to figure that out. तो इसलिए, and there's another way, ठीक है, there's a third method which is okay, this is what I'm trying to figure out, right? I'm trying to figure out what happens to rate with respect to OHN concentration and what's the order, right? That's what I'm trying to figure out. I'm trying to figure out this thing. अच्छा, तीसरा मेथड है you can convert this relationship into a linear graph. Linear graph किस तरह होगा कि यार log ले लो, log of 1/time, ठीक है, rate 1/time है, versus दूसरी साइड पे भी log ले लो. तो अगर log लोगे ना, it would become log of OH and concentration. तो आपने प्लॉट क्या करना है, just go and plot the log of OH and concentration every time you're changing the OH and concentration. Every time you're getting a different rate, log of 1/t. लेकिन this is the equation in the form of y is equal to mx, जिसके अंदर m is going to be your gradient. तो वो जो भी ग्राफ बनता है ना, you do several experiments, take different concentrations of OH ions, you get different वो जो आपका end point होगा different times होंगे, ठीक है, and you just plot a graph and you'll get several different points. यहाँ पे आ गया point 1, यहाँ पे आ गया, you'll do 3-4 experiments and the gradient would be your order. Is that clear?
जी सर.
तो ये भी कर सकते हैं, ठीक है, log of 1/t versus log of OH, and this one would be more accurate. Now, why would it be more accurate? क्योंकि अच्छा, more accurate compared to this method. क्या बारी बारी ना, वो किधर टेबल का है, ये वाला, इस मेथड से ज्यादा, मतलब you're doing the same thing, you're changing OH ClO concentration, you're trying to figure out कि what happens to the rate, right? लेकिन इसके अंदर एरर के चांसेस ज्यादा है. This method over here would be more accurate. Why? Because it's doing the same thing. लेकिन उसके अंदर ना वो जो ग्राफ बनेगा ना, उसके अंदर सारे एक्सपेरिमेंट्स की जो एरर्स है ना, वो एवरेज आउट हो जाएंगे when you draw the line. Is that clear?
जी सर.
तो 4 methods हमने डिस्कस कर लेंगे, how you're going to find the order. बस ये याद रखना कि ये चीज कि पूरा ग्राफ को कम ही लोग बनाते हैं. पूरा ग्राफ आप बनाते हो अगर आपको ना हाफ लाइफ मेथड यूज करना है, ठीक है, क्योंकि पूरा ग्राफ बना के एंड में टेंजेंट ही ड्रॉ करना है, तो आप सिंपली वो एक कोई एंड पॉइंट रख लो और 1/time कर लो, you'll just find rate, the initial rate. चलो, और केस में कैटलिस्ट का याद रखें कि किधर वेस्ट कैटलिस्ट, ये सारा तो हो गया. homogeneous and heterogeneous catalyst, you should know what the working is. और ये वाला खास तौर पे Fe2+ और Fe3+, do you remember this?
Sir, in terms of catalysts,
Yes.
no, sir.
अच्छा इसमें I mean this is for homogeneous catalyst. Okay, you must know and you must remember this one. What happens in this one is what is homogeneous catalyst? It's a catalyst which has the same state as the reactants, right? So there's this reaction which is you have to remember this specific homogeneous catalyst example. So you've got this reaction I2 plus S2O8 2 minus, और वो बना रहा है 2I minus 1 and 2SO4 2 minus. Okay, this is the reaction that's happening. And it's a very spontaneous feasible reaction. So you've got I2 2I minus 1, that's one reaction. Its E naught is 0.54 volts. And you've got S2O8.
Oh, sir, wasn't this the one where there's two negative ions that are reacting together, and so they need a catalyst because of the repulsion?
वही वाला है. ठीक है, this gains electrons, this loses electrons, and you get this equation over here. ठीक है. So it's a very feasible reaction. Sorry, 1.47 volts here. This is 2.01 volts. Higher potential gains electrons, lower potential loses electrons. So you've got this final equation, and the E naught cell is going to be higher potential minus lower potential, which in this case is going to be 1.47 volts. ठीक है, दोनों को subtract
Sir,
करो.
but if I minus is making I2, then why is
गलत
I minus in our
ये गलत लिखा है. This is 2I minus 1 and this one is I2 over here. ठीक है. अब this is what's happening, right? So now what you have to do is this reaction does not happen. Why does it not happen? Because both ions are negatively charged and they're going to repel each other. ठीक है. So which is why the reaction would not happen, and it's not going to be a spontaneous reaction. तो इसके लिए आप क्या करते हो? आप बीच में catalyst डालते हो. The catalyst is Fe3 plus or Fe2 plus or both. अच्छा, इसका मतलब है कि ये दोनों आपस में तो रिएक्ट करेंगे नहीं. So what's going to happen is this S2O8, because both of them are negative ions and they repel each other, S2O8 would react with Fe3 plus. This is going to gain electrons and this is going to lose electrons क्योंकि ये lower potential है. So this is your lower potential. And the equation that you get is को double कर लो so that the electrons are equal. So the first equation that you're going to get is S2O8 2 minus, और वो reacting with 2Fe2 plus, and the product is 2SO4 2 minus, and the other one is 2Fe3 plus. ठीक है, that's what's happening. And then the same equation, ठीक है, this one, it goes and does a reaction with iodine. ठीक है, it goes and does a reaction with iodine. तो एक तो ये equation बन गया. That's the first step that's happening. But then the same Fe3 plus Fe2 plus mixture also goes and reacts with iodine, where this is the lower potential, so it loses electrons, and that's your higher potential, it gains electrons. So what you get is you get 2I minus 1 reacting with 2Fe3 plus, and the products are 2Fe2 plus plus I2. And the value, and so your reaction has broken down into two steps, but you're getting the same product. You are getting if SO42 minus, and you're getting I2, which is exactly what you were getting over here as well. And Fe2 plus remains unchanged. शुरू में Fe2 plus था, बाद में फिर से Fe2 plus है. So it kind of remains unchanged. So your reaction has broken down into two steps. There's step 1, and you've got a step 2. And why is this? Why are these two reactions faster?
Sir, because now the ions are oppositely charged.
ठीक है, so they're going to attract each other and the reaction would be a lot faster. ठीक है, तो ये पूरा याद रखना है. ठीक है, इसका this needs to be remembered.
Sir, what would they ask for this? Like, would they have us, like, you know, do they expect us to memorize these equations?
They can ask you about what role is how does Fe2 plus or Fe3 plus catalyze this reaction. So you have to explain everything. Why is the reaction not happening? Why does this have a high activation energy? It's because it has negative ions. Okay? So everything related to this. So you have to memorize this. Okay?
ठीक है.
चलिए ठीक है. Let's continue. अफ्तारी के बाद probably continue करेंगे. ठीक है?
ठीक है.
Okay then. Take care.
ठीक है. Allah Hafiz.